let's have a look at Avogadro's law. And that's a relationship between essentially the mass and the volume of a gas. So we make two assumptions. The first and second are that the pressure and temperature of that gas are both held constant. So let's do a little thought experiment. We have a balloon that is not inflated. If we add more gas to it, in other words, we add more particles to it, the volume of the balloon will increase. So if we were to do an experiment on this, and we were to measure the increase in the number of particles and measure the increase in volume, we'd find that we have this type of relationship. Let's bear in mind that the number of moles is our measure here of particles, not mass. And we'll go into a little bit more detail with that shortly. So from this relationship, we can see that the volume is proportional to the number of particles or the number of moles. So in other words, if we get 0 particles in there, our volume would be 0. And as we increase the number of particles, we thereby increase the volume as well. So we can rearrange this equation as V equals some constant, given by this graph, times the number of moles or the number of particles. We can rearrange this equation now to get V over N is equal to our constant, which we can adapt to a before and after scenario. So we can have an initial volume, we can have an initial number of particles that we measure in moles for our gas, and we can have a final set of conditions, so we have a final volume and a final number of moles of our gas as well. Now, how do we use this practically? Well, let's have a look. Let's say we have this scenario. We have a balloon with an initial volume of 9.6 litres, and this contains 0.3 moles of krypton in this case. We're asked how many moles of krypton need to be added to give a final volume of 16 litres. So whenever I do these questions, I write out what we know, and then we can sort out what equation we need to use. So our initial volume is 9.6 litres, initial number of moles is 0.3, final volume is 16 litres. First of all, we want to find out our final number of moles. So our formula will be given by Avogadro's law. V1 over N1 equals V2 over N2. We need the N2, so we have to isolate. So we'll go through 3 steps. First of all, we multiply by N2 to get it onto this side at the top. We'll then multiply by N1 to get rid of this term. And then finally, we'll divide by V1 on both sides to get rid of the V1. And this leaves us with N2 equals N1 V2 over V1. And now we look and we plug in we put in our values. So we've got 0.3 moles of our gas initially. Our final volume is 16 litres over our initial volume of 9.6 litres. We have common units here. So if we do this calculation, we get a final value of 0.5, and our moles are our units. So this is the total number of moles in our balloon when we have a volume of 16 litres. Now if we remember back, our question asked how many moles need to be added. So we need to work out the number of moles added, and we do that by subtracting the number of moles at the end, the number of moles at the beginning, because we've added gas, from the final number of moles. So we get 0.5 minus 0.3, so we've added 0.2 moles of gas to the system.